Well, hello and welcome to skill lesson 13, reflecting a figure. So the last skill lesson we looked at, we were translating a figure. And the next transformation we're going to look at is reflecting a figure. So here we have, right here, are several functions that you could use to actually reflect a figure. The most common reflections that we'll perform are over the x-axis and y-axis. The second most common, use the line y equals x and y equals negative x. So here are some functions for you to use. If you feel like memorizing, go for it. I think the way I'm going to show it to you, you might understand it a little bit more instead of trying to memorize, x negative y, negative x y, y x, and so forth. That can, especially for a test, the chances of us memorizing that on top of the rotations, which we're going to see in a little bit, can be a little too much. So let's go and dive into our practice here. We'll bypass through the example. So it says practice A, it says use the mapping to transform the vertices of each figure, then graph the image. Now, for the sake of the video, I am simply just going to perform the transformation. I'm not so much going to spend time graphing it. However, I will graph a couple because I think some of you will really start to notice a trend here in terms of how to perform these transformations. So again, there's multiple ways to do this. You can memorize the functions. For example, on number 1, it tells us to do a reflection about the line of the x-axis. So you might notice what that function says, or really understanding what it's doing. If we're reflecting something over the x-axis, let's say we're starting in the first quadrant. If we're reflecting over the x-axis, we're reflecting it over this horizontal line here. So we're not going to move it left or right at all. We're simply going to flip it over that line so that it still stays in the same line left or right, but it flips vertically. So if you notice the function for reflection across the x-axis is that the x value doesn't change, the y value changes signs. Because we're literally flipping it over this horizontal line, so technically flipping it vertically. So that's one way to approach it. So if j is located at negative 3, 4, j prime will be at negative 3, negative 4. Notice all I did was change the sign of y. So we'll do the same thing with k prime. K is located at 1, 4, so k prime will be located at 1, negative 4. L is located at 0, 0, so L prime, again, we don't have to write a negative 0. There's really no sign for 0 because it's nothing. So L will actually remain at the origin, which is 0, 0, and M, or M prime, if M is located at negative 1, negative 1, we're just going to simply change the sign of our Y, so it'd be a positive 1. So J prime is located at negative 3, negative 4. K prime is located at 1, negative 4. L prime still at 0, 0. And M prime, negative 1, 1. Okay, so another way to approach this is to really understand what we're doing when we perform a reflection. So let's take a look at item 1. I went ahead and graphed the pre-image, J, K, L, and M. And so our task is still the same for item 1. Our job is to reflect over the x-axis, which is actually this line right here. So in a reflection, one of the easiest ways to handle reflection is ask yourself how far is that pre-image point from the line of reflection. And then what you're going to do to produce the image is move that point that same distance over the line of reflection. So for example, J is 1, 2, 3, 4 units from the x-axis, which is our line of reflection. So J prime has to be 4 units below the line of reflection. So 1, 2, 3, 4, which would actually be J prime located at negative 3, negative 4. So if you go back and look at our work, you see that it was, in fact, located at the y value change from positive 4 to negative 4. So we'll do the same thing with K. K is located, kind of clean this up a little bit right there. K is located 1, 2, 3, 4 units above the x-axis, so now K prime will be 1, 2, 3, 4 units below the x-axis. So still be at 1, -4, or be at 1, -4. Now L is pretty interesting, not just because it's 0, 0. I mean, you're thinking anything times 0 is still 0, or there's no positive or negative 0. One of the reasons that L in this case will not move is because L is on the x-axis, or the line of reflection. So if a point is 0 distance from the line of reflection, it's going to move a 0 distance over the line of reflection. So L and L prime are in the same location. Now you might be asking yourself, well, how did JK move down but M is moving up? It's that concept of however far a point is from the line of reflection, that's how far it has to move. So M is 1 unit below the line of reflection, so we have to move it 1 unit above the line of reflection. So we will be located at -1, +1 for M prime. So you can use this idea of distance over the line of reflection to, especially on the second set, make it a lot easier on us. So I'm going to go and clear that out.
Miss Tate, bus the office, Miss Tate.
Sorry about that. Just so many announcements on a day such as today. Now let's look at item 2. We have the same set of coordinates, but now we're asked to reflect it about the line y equals x. Now I had a lot of students ask me what the line y equals x is. So let me show it to you on a graph. So y equals x is the most basic line there is. It's the line where y and x is the same value on the coordinate plane. Or another way to look at it, this is technically slope-intercept form. It has a understood slope of 1 and a y-intercept of 0. That's why it's the most basic line. It has a slope of 1, y-intercept of 0. So it's actually the line that passes through the origin and has a slope of +1. This is the line y equals x. And of course, it goes down into the negatives as well. -1, -1, -2, -2, -3, and so forth. So these pink points actually represent the line y equals x. So we're asked to reflect over that line. Now, this might look a little bit more complicated because it's not just simply moving our shape up or down. It's kind of flipping it diagonally, if you will. Now, there are in fact, two points on here that are on the line of reflection. If you notice, L is 0, 0, and M is -1, -1. Those 2 points are on the line of reflection. Just like we said on number 1, points on the line of reflection will not move. So L and L prime will be located in the same place, and M prime will be located in the same place. The only 2 points that are actually going to change are J and K. So let's find out where J prime and K prime are. So the function for the line y equals x is each point we'll go to, we simply swap y and x. We literally invert the two coordinates. So -3, 4, J prime will now be located at 4, -3, which would be +4, -3. So J prime will actually end up down here, which is located at 4, -3. Now this one's a little bit more complicated to see because it's a diagonal line, but you can approach it the same way as, the whole point here is you're supposed to be able to connect these two corresponding points such that this is a 90-degree angle. When we learned about reflections, we said that the line of reflection is also called a perpendicular bisector. So not only is however far J is to the line of reflection,
Miss Tate,
my goodness,
the office, please, Miss Tate.
Sorry about that. But when you actually connect these corresponding points, you should be able to find a 90-degree angle there. But it is a little more complicated when doing this distance idea across a diagonal line. Let me see if I can back that up, get rid of that line there. So let's finish out where K prime will be located. So if K is located at 1, 4, then we're just going to swap those two coordinates. So K prime will be located at 4, 1. So we'll go over 2, 3, 4, and down 1. So K prime will actually be located here. And if I could loosely draw it, remember L and M are in the same location. That looks a little off. Let me make sure that I actually did my counting correctly. Oh, I see what I did. I did 4, -1 for K and K prime, and some of you are probably freaking out. It should be 4, 1, which should actually be right up here. That makes more sense. There we go. Much better. So you can see here, it literally flipped over this pink line, which is the line y equals x. Now let's take a look at item 3. So if you want to write those vertices here, I guess I could do that real quick. So J prime is going to be located at 4, -3. K prime is going to be located at 4, 1. L prime will still be in its same location, and M prime will be in its same location, simply because they were on the line of reflection. Now let's look at item 3. They want us to now reflect the same coordinates over the y-axis. Now, the same way we approach a reflection across the x-axis, we can view a reflection across the y-axis the same way. So if we're reflecting across the y-axis, we're actually reflecting over a vertical line. So if we have a point in the second quadrant, it's going to reflect over this vertical line and end up in the first quadrant. So notice it's not going to move up or down at all. It's just going to move left or right. In this case, it'll move right. So all we're doing is we're inverting the x value. So if J is located at -3, 4, J prime will be located at +3, 4. K prime will, if K was located at 1, 4, K prime will be located at -1, 4. Now L, because it is 0, 0, L prime will still be 0, 0, and that's because, again, 0, 0 is on the line of reflection. It's on the y-axis. The point 0, 0 is on both the x and y-axis. So that's why it's not moving in 1 or 3 or even 2, because it's always been on the line of reflection for these examples. So M prime, if it was located at -1, -1, it'll now be located at +1, -1. Now, again, I do invite you to graph item 3. Again, the practice, I'm not going to spend as much time graphing, although I believe you can accomplish that on your own. Now let's look at item 4. Now, the main difference between item 4 and item 3 is we're using the line y equals -x. So let me show you that line. So the line y equals -x has, in this case, an understood -1 slope and still a y-intercept of +0. So it still goes through the origin, but it has a -1 slope. So it literally goes the exact opposite direction as the previous line, y equals x. So now we're going to reflect these points over that line. So the function for the line y equals x was simply swap x and y. But the function for this reflection is you don't just swap x and y, but you change the sign of both. That's because literally y equals -x is the opposite of y equals x. So -y is the opposite of y, and -x is the opposite of x. So we're going to take each of our pre-image points and swap them and change both signs. That's how we're going to approach this one. So if J is located at -3, 4, J prime will be located at +3, -4. If K is located at 1, 4, K prime will be located at -1. Oh, correction, -4, -1. L prime, well, because it's still going to be on the line of reflection, will be at 0, 0, and M prime. If M prime is -1, -1, swapping and changing both signs will end up at 1, 1. Of course, I invite you to graph here, but just for the sake of practice, I just want to make sure we know where the coordinates are at. Now, this concept of distance from the line of reflection is really going to come in handy on this next set here. If you notice, even on example, they ask you to reflect across the line x equals 1, and we'll see some that have a y equals as well. So these functions that we're about to see don't necessarily have a function notation for them. We have to really understand the concept and the distance idea that I was referring to in that first practice A. So we're going to really use graphing here for us to understand how to perform reflections about these lines: x equals 4, y equals -1, x equals 0, and y equals 3. Really going to rely on graphing here. So our first reflection on this set is going to be about the line x equals 4. So let's clear all this out. So x equals 4. Let's think about what that really means. So x equals 4 right here. Well, not only does x equal 4 there, but it also equals 4 here, and here, and here, and literally every single point on this vertical line. So x equals 4 is a vertical line that passes through the x-axis at +4. So a vertical line is x equals some number. In this case, this is x equals 4. So what we're going to do, because there's not really a function to perform these, is we're going to just consider how far each of these pre-image points are from the line of reflection and then flip them over that line. So J is located 1, 2, 3, 4, 5, 6, 7 units from the line of reflection. So we need to go 7 units to the right. 1, 2, 3, 4, 5, 6, 7. So J prime will now be located at 4, 7, 8, 9, 10, 11, 11, 4. J prime is located at 11, 4. Now, K, if you notice, it's actually a little bit closer to the line of reflection than J was. So K was located 1, 2, 3 units from the line of reflection. So when we flip it over that line, it needs to remain 3 units from the line of reflection. So K prime will be right here, which will be located at, I believe, 7, 4. Now let's look at L. Now, notice L and M in this case are not on the line of reflection, so they have to move. So L is located 1, 2, 3, 4 units from the line of reflection. So we have to reflect it 4 units over the line of reflection. So L prime will end up here, which is actually located at 8, 0. And last and certainly not least, M prime. M is, I believe, located 5 units from the line of reflection. So we need to go 5 units on the other side of the line of reflection, which will be right here. And it'll be located at 9, -1. So here we have a reflection across the line x equals 4. Now, if you notice when you're graphing, this image that I just graphed, K prime, L prime, M prime, J prime, should be the same size and shape of our original figure, because a reflection is considered a rigid motion. Now let's go back. Actually, I think number 6 is a reflection across the line x equals 0. So a reflection across the line x equals 0, well, let's ask ourselves, where does x equal 0? Well, x equals 0 at every single point on this line. Now, this line has a special name on the coordinate plane. It's called the y-axis, right? So x equals 0 on the y-axis. So let me see if I can draw it in a different color. So the same way you approach a reflection across the y-axis, we're going to do the same thing here with a reflection across the line x equals 0. So J is 1, 2, 3 units from that line, so we're going to go 3 units over the line. So J prime will be located at +3, 4. Now, K was actually on the right side of this line of reflection, so it now has to flip over to the left. It has to, every single point has to flip over that line. Or in this case, however far it is from that line of reflection, that's how far it has to flip over. So K was 1 unit away from the line of reflection. It has to remain 1 unit away on the other side. So it'll be located at -1, +4. Now L, again, is on the line of reflection. So L and L prime are going to be in the same location. And last, M prime, use a different color so you can see it. M was located 1 unit to the left of the line of reflection, so M prime has to be 1 unit to the right of the line of reflection, will be at 1, -1. So it kind of flipped, and it's still kind of overlapping itself. That's because part of our image was already going across the line of reflection itself. But that is a reflection across the line, x equals 0, or in this case, the y-axis. Last one, and certainly not least, even for this entire skill lesson, number 8, a reflection across the line y equals 3. So if a vertical line, which runs up and down, is x equals some number, then y equals some number will actually represent a horizontal line. So we are told that the line is y equals 3. So ask yourself, where does y equal 3? Well, y equals 3 right here, and right here, and right here, and here, and here. Every single coordinate on this line that I'm about to draw, y is the same value. It's 3. So let's go and draw that line here. And now let's reflect each point across that line. So J, being 1 unit above that line, now needs to be 1 unit below it. So J prime will be located at -3, +2. K, again, 1 unit above that line, now has to be 1 unit below it. So K prime will be located at +1, +2. L, now this one's going to change because it's not on line reflection, being 3 units from the line, now has to be 3 units above the line. So L will be located up here. L prime will be located at 6, 0. So don't always assume just because it's 0, 0, it's not going to move. It depends on where it is in relation to the line of reflection. Now last, M prime is 1, 2, 3, 4 units from the line, so we need to go 4 units up. And I think I'm going to be pretty close to going off my screen here. That's okay. M prime will be located at -1. Actually, this would be, I'm noticing, this would actually be 0, 6. So this would actually be -1 and 7. 2, 3, 4, 5, 6, 7. Yep, looks good. So that is a reflection across the line y equals 3. So that is the end. Of course, put the image vertices on the actual paper here, and hopefully that helped your understanding of how to perform reflections on the coordinate plane. Thank y'all for watching.